All right, so graphing rationals. So we're spending the next 2 days on graphing rationals. Today we'll do the notes. Tomorrow we will do the assignment. So it's very similar. It's been a while since we've done any graphing, but I try to have the same setup. So our vertex form for a rational, well actually, what's the parent function of a rational first? What's it? Y equals, what do you think? Y equals x would be just that's not a rational. Remember, it's a fraction. So it's close to x, but what?
X plus b.
No, that's the line graph.
Y equals x over b over x.
What should be over x?
Something over x. 1
So
over x.
the parent function is just y equals 1 over x. The vertex form is y equals a over x minus h, and then plus k on the outside. So we're still using our h's and k's and our a values. And so the attributes, the a is our leading coefficient. Anybody remember what the h is? I think the last time we graphed was November, so it's probably been a while. It's the opposite sign of the inside value. In this case, it's what's in the denominator. And then k is our ending constant. Just a single number. So if our a value, the absolute value of a on top, if it's greater than 1, what do you think happens to the graph? Does it stretch or compress when it's greater than 1? Yeah, stretch. The graph stretches. So that means when it's between 0 and 1, the graph compresses. That means it flattens out. And then, what do we usually say if we have a negative a value about the graph? What's the transformation we always say when it's negative out front? What's that do to our graph if it's negative? Turned upside down. Do you remember the word that we use? Reflection. So now instead of reflecting across the x-axis, we're saying it reflects across the asymptote. It reflects across the asymptote. Asymptote. And so now the domain is all reals except x can't be h. It can't be the h value. That's where an asymptote is at. The range is all values except it can't be k. And so that means our asymptotes are at x equals h and y equals k. And so now instead of having a vertex, we have an intersection of our asymptotes, and that's at HK. Just like where before, that was where our vertex reached, was at HK. So for rationals, that is where the two asymptotes intersect. So the H value now, it still is our horizontal shift, but it identifies the vertical asymptote. So it identifies the asymptote that is up and down. And it's x equals h. The k value still moves us up and down, but it actually identifies the horizontal asymptote. And that is as y equals k. So that's the asymptote that is a line going across. And so the asymptote shifts left and right. So remember, the h is the opposite sign. So to move left, it has to be positive. To move right, it's negative. So this is moving left and right. So just remember, h, opposite. The x value, it always lies to you. The number that's always next to the x is lying to you in terms of which direction. And then the k value, it stays the same. It moves up and down. When it's positive, it moves up. When it's negative, it moves down. When we are to graph the parent function, we must create a table that includes positive and negative x values. And so anytime we're graphing these, think I need to make a table to plot points. And so I'm going to choose some positive and some negative values here. I'm going to use a -2, a -1, a 1/2, a 2, and a 4, just to kind of show you. And so the parent function is y equals 1 over x. So when x is -2, y is -1 over 2. When x is -1, y is -1 over 1, or just -1. When x is 1/2, 1 over 1/2 is 2. Because when you're dividing by a fraction, you multiply by its reciprocal. And then we have 1 over 2 and 1 over 4. So those would be the points you would plot for the parent function. If we have an a value, it multiplies our vertical movement. So just plugging in some values here for x, 1/2, 2, and 3. So 1 over 1/2 is equal to 2. 1 over 2 is just 1/2. 1 over 3 is 1/3. But then we have to multiply each of them by 6. So our y values for 1/2 is 12. For 2, it would be 3, and for 3, it would be 2. So because we have y equals 6 over x, it stretches it by a factor of 6. All right, which way, if you have y equals 1 over x plus 3, which direction is that shifting? Is it shifting left or is it shifting right?
Right. Or left.
Left. Why?
That's positive.
Because it's positive. It lies to you. The x lies to you. So it shifts 3 to the left. So that means 3 to the left, we will have an asymptote right there. And the graph looks something like that. So it shifted left 3. Which way does this last one, 1 over x plus 3?
Right.
Remember, the 3 is outside, so if it's outside, it's going up or down. It's going to go up 3, yeah. So our asymptote shifted up 3. And so our graph looks something like this. Moved up 3. Everybody have this?
Yes. No.
Need a second, Kylie? Who wrote in green pen? Because they didn't put their name. Come write your name on it. Everybody got this page? Can I flip it over? Okay. So we have a couple examples here that we will work through. All right, so we have y equals 1 over x plus 2. So first, what would be our transformation? Kenzie, what would be our transformation? For y equals 1 over x plus 2. Up 2. So we just say shifts up 2. So when it shifts up 2, so normally our asymptotes are always at x equals 0 and y equals 0. When we shift up 2, that moves our asymptote up to y equals 2, and then we still have x equals 0 because it didn't shift left or right. So we can put our asymptotes in there. Now when we want to create a table, so we have our x values, and then we have 1 over x plus 2 is our y value. So, Sadie, give me an x value that would be to the right of the vertical asymptote. Just pick any x value. 2, okay. So if x is equal to 2, then we plug it in. So 1 over 2 plus 2 is 2.5. So we have a point at x equals 2 and y equals 2.5. So there's 1 point. And then I want to show you what happens when we put in 1/2. So we do 1 over 1/2 plus 2. So what's 1 divided by 1/2? 2. So that becomes 2 plus 2, which is 4. So at 1/2, we're up at 4. So on this side, our graph is going to look something like that. And then Kylie, can you pick a negative number?
4.
So -4, okay. So when we plug in -4, we get 1 over -4 plus 2, which puts us at 1 3/4. So we go x equals -4, and then we're at 1 3/4, somewhere up there. And then if we pick -1, 1 over -1 plus 2, it's going to put us at 1. So it's going to put us right there. And so the graph is going to look like something like this. So our graph is always going to be basically like kind of two things being opposite of each other. And if you folded it kind of diagonally, they would fold over each other. So Olivia, what would be our domain? So flip it over and look at what we say about domain. There could be. We can just make it simple though. So what's the x value we can't pick? Which x value would put us on an asymptote? That would be the y value. So as you look, like, which asymptote is up and down? Can you guys help her? Which asymptote is up and down? Where's it at? X equals what? At x equals 0 is the asymptote that's up and down. So that means for our domain, rather than write from negative infinity to 0 and from 0 to infinity, we're just going to say domain. The set of all x's such that x can't be 0. And so range we can do the same way. Troy, what would be the range? The set of all y's such that what?
All x's.
What is y not allowed to be equal to?
K.
And what's our k value? What's the k value on this one? Hayden's got it. How much did we shift? What was our shift?
2.
So we shifted up 2. 2 is our k value. So our domain, for these ones, it's just easier to write what x and y can't be equal to. Okay? All right, let's look at the next one. Y equals 1 over x minus 3. So, Kaylin, what would be our transformation here? Which way are we shifting? Doesn't reflect. There's no minus out front. Close, Matthew. What do you think, Caleb? To the right 3, because our x's lie. X minus 3 means it shifts to the right 3. Good. So we'd say right 3. And so what that means is our asymptote that had been on the y-axis is now at x equals 3. We didn't shift up or down at all, so now our other asymptote is just along the x-axis. And so y equals 1 over x minus 3. And so I think you guys will start to see what these graphs do. when we pick, give me a number, Emily. What's an x value you want to graph? See.
Oh.
Not 3. Anything other than 3.
6.
6, okay. So when we plug in 6, y equals 1 over 6 minus 3, which is 1/3. So at 6, our graph would be at 1/3. And then, so that means it's going out like this to the right. As we move closer to the asymptote, so if we pick 3.5, 1 over 3.5 minus 3, that's going to be 1 over 1/2, or 2. So you can kind of see when we are 1 away from the asymptote, it starts to go up. So we're kind of like this, and like that. And then the other side is going to look the same way. So if we picked -6, that's 1 over -6 minus 3, or -1 over 9. So at -6, we're almost right at 0. And then if we said at 2.5, right next to the asymptote, 1 over 2.5 minus 3, that's going to put us at -2. And so this graph is going to come and look something like that. Okay? So if you can graph one side, the other side reflects basically about the origin. It rotates around. And so what's our domain and range here, Becca? What x value can the domain not be?
3.
3. What's the y value that we can't have?
0.
0. Good. All right. And then tomorrow we'll go over example 3 at the beginning of class. And that will be it.